Today, we shall study about bandwidth of signals in communication system of modern physics. Bandwidth of signals in a communication system, the message signal can be voice, music, picture, or computer data. Each of these signals has different ranges of frequency. The type of communication system needed for a given signal depends on the band of frequencies, which is considered essential for the communication process. For speech signals, frequency ranges 300 Hz to 3100 Hz is considered adequate. Therefore, a speech signal requires a bandwidth of 2800 Hz to 300 Hz for commercial telephonic communication. Transmit music. An approximate bandwidth of 20 kHz is required because of high frequencies produced by the musical instruments. The audible range of frequencies extends from 20 Hz to 20 kHz. Video signals for transmission of picture require about 4.2 MHz of bandwidth. A TV signal contains both voice and picture and is usually allocated megahertz of bandwidth for transmission. We have considered only analog signals. Digital signals are in the form of rectangular waves as shown in figure 1. One can flow that this rectangular wave can be decomposed into a superposition of sinusoidal waves of frequencies nu naught, 2 nu naught, 3 nu naught, dash and nu naught, where n is an integer extending to infinity and nu naught brought 1 over t naught. The fundamental nu v nu naught plus second harmonic to nu naught and fundamental nu naught plus second harmonic to v naught plus third harmonic to v naught are shown in figure to illustrate the fact. It is clear that to reproduce the rectangular wave shape exactly we need to superimpose all the harmonics nu naught to v naught to 3v naught, 4v naught, dash which implies on infinite bandwidth. However, for practical purposes, the contribution from higher harmonics can be neglected, thus limiting the bandwidth. As a result, received waves are a distorted version of the transmitted one. If the bandwidth is large enough to accommodate a few harmonics, the information is not lost and the rectangular signals is more or less recovered. This is so because the higher the harmonic, less is its contribution to the waveform bandwidth of the transmission medium. Similar to message signals, different types of transmission media offer different bandwidths. The commonly used transmission media are wire, free space and fiber optical cable. Coaxial cable is a widely used wire modem which offers a bandwidth of approximately 750 MHz. Such cables are normally operated below 18 GHz. Communication through free spaces using radio waves takes place over a very wide range of frequencies from a few hundred of kilohertz to a few gigahertz. This range of frequencies is further subdivided and allocated for various services as indicated in Table 1. Optical communications using fibers is performed in the frequency range of 1 terahertz to 100 terahertz, microwaves to ultraviolet. Optical fiber can offer a transmission bandwidth in excess of 100 gigahertz. Spectrum locations are arrived at by an international agreement. The International Telecommunication Union administers the present system of frequency locations. Some important wireless communication frequencies band services, frequency band and comments. A standard AM broadcast 540 to 1600 kilohertz, FM broadcast 88 to 108 megahertz, television 54 to 72 megahertz, and at very high frequencies VHF 76 to 88 megahertz, 174 to 216 megahertz, ultra high frequency, cellular mobile radio 896 to 901 megahertz, 846 to 935 megahertz, mobile to base station and base station to mobile, satellite communication 5.925 to 6.425 gigahertz, 3.7 to 4.2 gigahertz, uplink and downlink. Propagation of electromagnetic waves. In communication using radio waves and antenna at the transmitter radiation, the electromagnetic waves which travel through the space and reach the receiving antenna at the other end. As the EM wave travels away from the transmitter, the strength of the wave keeps on decreasing. Several factors influence the propagation of EM waves and the path they follow. At this point, it is also important to understand the composition of Earth's atmosphere as it plays a vital role in the propagation of EM waves. Now, ground waves. To radiate signals with high efficiency, the antenna so have a size comparable to the wavelength lambda of the signal, at least lambda by 4 at a longer wavelength. It means at lower frequencies. Longer wavelength and lower frequencies. The antenna have large physical size and they are located on or very near to the ground. In a standard AM broadcast, ground-based vertical towers are generally used on transmitting antenna. For such antenna, ground has a strong influence on the propagation of the signal. The mode of propagation is called the surface wave propagation, and the wave glides over the surface of the earth. A wave induces current in the ground over which it passes, and it is attenuated as a result of the absorption of energy by the earth. The attenuation of surface waves increases very rapidly with increasing in frequency. The maximum range of coverage depends on the transmitted power and frequency, less than a few megahertz, as shown in the table 1 for a stratosphere, troposphere, a part of a stratosphere, part of a stratosphere, and part of mesosphere, and the thermosphere, as shown in table 1.